Hello and welcome to another LeetCode problem. Today we're going to be doing the problems of the day for June 21st, minimum cost to make array equal. And I definitely think this question is quite tricky, and to be honest, I'm not a huge fan of it because I think without having a math background, it's not super intuitive. So, and in fact, I'd say it's very hard to solve without having a math background because no matter what solution you have, there are two solutions to this. They're both not intuitive. So I'm just going to quickly describe the first solution after going over the exact problem, and then we will do the second one, and I'll describe the second one and try to help you get the intuition for them. So we have a nums and we have a cost. So let's just say we have this 3, 5, 2. Okay, we have a cost. And pretty much what we need to do is we can either increase or decrease every single number in our nums by 1 at a time, and that's going to cost us cost amount of like money or whatever the operation takes, right? So we can increase or decrease any element by 1, and the cost of doing that is in this cost array, and then these elements are together, right? So if you increase index 0, then the cost would be at index 0 and the cost and so on. So let's take a look at the example. So if we increase they're saying the fastest way to do this is to increase every element to 2. So let's figure out what that would be. So we would increase 1 to 2, which would be cost 2. We would decrease 3 to 2, which would be cost 3. We would decrease 5 to 2, which would be, so we'd have to decrease it by 3 numbers times 1. And then 2 is already 2, so we don't have to do anything there. So that's going to be 8. Okay, and it's showing we can't do anything with a smaller cost. And so for the second example, everything's already at 2, so the cost is 0. So I will just say, I'll briefly describe the first solution. So for the first solution, pretty much what you do is you sort the numbers. So you have something like this. And then you have to know, and I don't know how they expect you to know this, that, so you can know some things, right? Like, I think it's reasonably obvious to figure out that like your solution has to be within the range of the min and max number, right? So somewhere between 1 to 5. Because anything bigger or smaller wouldn't make any sense because it would just be strictly worse than like let's say we use 6 instead of 5. Well, we can just use 5 and 5 will be cheaper, right? Like if we try to make everything turn into 5, the 5's already a 5, and then these numbers would have to get increased by some amount. But then if we use 6, these numbers would have to get increased by more, and 5 would have to get increased. Same thing for 1. We wouldn't want to use a number less than 1 because 1 would strictly be better than all those. So you can get the intuition that the solution has to lie somewhere between those, but I think to actually make it complete on LeetCode, you have to realize that not only that, you have to realize that the solution is actually one of the numbers in the nums array, which is definitely not like intuitive, because you might think there might be some number in between them that it can also be, like let's say 1, 2, 3, 5. How do you know that like 4 is in a solution? It's definitely not intuitive. But I would say once you're given that hint, it's doable, but it's still not easy. And so pretty much what you do for that solution is you make a prefix sums array of the cost of increasing every element by 1, and then you make a suffix, or I guess you can just use a prefix sums array because the suffix would be the same, right? The cost of increase and decrease is the same, so you can use the same array. But you make an array of the cost of increasing every element by 1, and then you just go through your numbers and you try to figure out like what would be the minimum here. And that would look like something like this. Like for example, if you try to make everything 1, you would say, okay, this 1 is fine. Now all of these I need to decrease. So then you have some prefix sums array with 3 numbers where you'd have some numbers. And so you take whatever the cost is to increase all of these here, right? So let's say you're trying to make, or by decrease, you would try to figure out like what would be the cost of that, and then like how many times you have to do it. I'm not going to go too much in detail, but yeah, it's pretty much a prefix sums, and then you're going number by number to try to figure out like what's the total. So the solution we are going to go over is actually a binary search solution, also not super intuitive. So you can realize something, but it's not super intuitive as well. So you can realize that, like I said, because you know that once our array is sorted here, so let's actually delete all this. So once our array is sorted, we actually don't even need a sorted array, but when we have an array, we know that the number that we're going to choose is going to be somewhere within the range of 1 to 5. Because anything bigger than 5 is going to be strictly worse than 5, and anything less than 1 is going to be strictly worse than 1. And so what you need to figure out for this binary search, once again, also not intuitive, is there is only one solution And if you know that there's only one solution, then it becomes a little more intuitive. But if you know that there's only one solution, then you know the graph of that is going to look something like this, where it's either going to be like a V or a U or whatever, where there is some, if this is the cost and this is the number, that the cost is going to decrease at some point and it will reach the minimum. So it's actually, let me think about this. Yeah. So something like this. So the cost is going to decrease and then there will be some minimum and then it will keep increasing, right? So like, let's say, for example, we know that like for 5, the cost might be here, right? For number 5, for this 5. But you know that like for number 6, it's going to be strictly greater, right? So it's going to be somewhere up here and so on. Same thing, the cost for 1, let's say this is 1. The cost here is going to be at some point here, but then anything smaller than 1 is strictly increasing. And then there is some solution somewhere that's down here. And so once you know that, once you know the graph looks like this, so we can figure out that works like that for one number, even if you can't figure out it works like that for all numbers. Because for example, let's say we just have one number, right? So we have a number 1, and then we try to make it whatever, like there's going to be some number that we want to make it, right? And so the minimum is always going to be the number that it already is, right? So we try to make a 1 turn into a 1. So the cost is going to be the minimum here, but then if we try to make a 1 turn into a 0 and -1 and so on, the cost is going to increase this way. And then if you try to make a 1 turn into a 2, 3, 4, 5, whatever, that's going to increase that way. And so if you think about it, if you just take, so every single element in itself makes this V graph. So all of these elements together are pretty much additions of this V graphs. So it's like if you have multiple V graphs or parabolic graphs, it might make it a little bit easier to figure out. Like say you have a parabolic graph, right? Like ax squared plus bx plus c. And you add another parabolic graph, right? So let's say this is another letter, like dx squared plus, ex plus c and so on. If you add a bunch of parabolic graphs, you're going to get a parabolic graph. And so it's the same thing with these V, like I think they're called convex graphs. If all of these elements have convex graphs, you're just going to have a bunch of these convex graphs that you're going to be adding. And so if you add a bunch of these convex graphs, that means your overall graph for this whole thing for some minimum cost is going to look like this as well. And so now that you know that, you can figure it out. But like I said, I don't think it's super intuitive to figure that out. So now that you know that there is some minimum, and that minimum has to be between 1 through 5, now it's pretty straightforward to do. Like from there, you should be able to do that. And so what we're actually going to do is we're going to do a binary search. So now that we know that like we can take a min element and a max element, let's figure out what we do from there. So we're going to have a right and a left, right? So our left is going to be the min element. And then our right is going to be the max element. Then we simply have a function that, so by the way, so how would we do this in a brute force solution, right? So the brute force solution would just be try every single number from the minimum to the maximum, and then figure out like what would be the cost of that, right? So try, so if you have this 1352, you would try, so if this is nums and this is cost, and then we try 2314, right? So the brute force would just say like, all right, let's try to make everything a 1. What's the total cost? Let's try to make everything a 2. What's the total cost? And so on. So you try to make it from 1 through 5. And the complexity of that solution would be max of n minus min of n, right, times length of n. So let's just call that like n or something, because you would have to go through the whole array every time. So that could be like an n squared solution, which is not great. Now we are improving upon that with a binary search, and the reason is because now that we know that there's a min and a max, and the graph looks like this, now we can actually do something really cool, and in which case, so we have some numbers. Let's just say we get some index. So if we get some index I, we can just compare whatever the cost is at that index and the cost at I plus 1. And there's a few cases. So if the cost at I plus 1 is lower, and you want to use two indices that are right next to each other, and I'll show you why in a second. So if the two indices are right next to each other, if the cost of I plus 1 is less than I, then you know our solution is going to be somewhere to the right of I, right? So we know it has to be to the right, no matter what, right? So if I was over here, yeah, so that would be the only way for I plus 1 to be smaller, right? If I plus 1 is smaller, that means that this minimum point is going to be to the right of I, okay? Now we have some other cases. So what if I plus 1 is greater than I? And think about how that could happen if you have the points are next to each other. Then I would have to be either this minimum or somewhere here, and then I plus 1 would have to be over here. In which case, our solution is to the left of I. And so you can just compare I to I plus 1, figure out where the minimum is in relation to those, and then from there, you can just update your left and your right accordingly until you search through the whole thing and you get the minimum. And so now, so this used to be this, but now let's say this min and max, let's just call that like some other element, like m. So it used to be mn, but now we have, if you think about it, now for these elements, we don't actually have to check every single element. It's just going to be log of m times n. So we improved from a quadratic to a logarithmic, right? And so hopefully that makes sense to you. And like I said, this is not super intuitive to come up with this convex thing, but once you do, it should be reasonably intuitive on how to get the answer. It's just a standard binary search. And so let's code that up. Okay, so we are going to need a helper function to calculate the cost, so let's do that. So we'll just call that def, maybe total cost or something. It's going to take a value that we're going to try, and then we need to calculate the total cost of transforming every single number. And so it's going to be pretty straightforward. So we're just going to have a total variable, and then we are just going to go through every single number in nums and the according number in cost. And so we can just do like this. You can do a zip, but I'm not going to do it. So for every single number in nums, what we need to do is we need to get a difference. And so the difference is going to be the absolute value of nums I minus, and this is going to be the value. And so then we know how many times we need to change the value. So now we just have to multiply that by the according index and cost. So total plus equals difference times cost I. Okay, and that should do it. And then we can return the total here. Okay, so now that we have the cost, this is annoying. Okay, so now that we have the cost, what we need to do is we need to do the actual binary search. So let's do that. So what we're going to actually do is we're going to have the left and the right as always, but it is a little annoying because you have to compare every element to the element to its right, so we do need to add a little bit to our standard template. So let's just say left, right equals, and remember, the left is going to be the minimum of nums, and the right is going to be the maximum of nums. And then what we're going to have is we're going to have our result equals total cost. We'll just have a default value, total cost left, let's say. We just want something to compare to. Okay. So now we want to have while left is less than or equal to right. And so because we are comparing every element to the element to its right, so we can have a case where we're on the last element. So we'll just say when we're on the last element, left has to equal right. So we'll just check for that. So if left equals right, then we can do some stuff here. We can just say result equals min of result and total cost left. And we can break here to make sure we don't have any issues. So now we did that. So now left is guaranteed to be less than right. Now what we need to do is we need to actually get the value at the pivot, and then we need to get the value to the right of the pivot. So let's get the pivot first of all. So pivot is always left plus right 1, 2, or integer divide. So now we can say like pivot val equals cost of, or this is total cost of pivot. Then next val equals total cost of pivot plus 1. And then so we need to compare them. So if pivot val is less than next val, so remember in our picture, if I still have it up, yeah. So if the pivot val is less than next val, that's this case right here, we need to go left. So let's do that. And we also need to update our result. So the pivot val could be the result, so let's update that. So res is min pivot val res, and then we're going left, so right equals pivot minus 1, else. So if the next val is less than the pivot val, that means that our pivot is over here. Oh, let's actually think about that. So if we have this, if the next val is less, so our pivot val is here, and then our next val is here. So it's a little small, but yeah. So then we need to go this way. And we also need to update the result just in case, because the next val could technically be that value. So min res and then next val. And then we need to go right, so left equals pivot plus 1. Okay, and that should give us the right result. So let's see here. See if we screwed anything up. Pray. Okay, nice. Okay, so this is going to be space efficient because, and I'll just go over the space and time here. So for the time, so what are we actually doing, right? So this cost is going to take O of n times. So we already have O of n because the cost goes through the whole nums array one time. Now we are doing this cost how many times? Well, we're actually doing it log. So like I said, if you say m equals max of nums minus min of nums, then you are doing it n log m times, because every single time we have to go through log m. And so yeah, we have to go through this many numbers. We have to go through this many numbers, and then, sorry, every single time we are going through the array. So it's n log m, because we are going through m a logarithmic amount of times. We keep dividing that by 2 every time, but n, every time we go in there, we have to do this n. It would technically, once again, be like a few times n. It would be like 2n or 3n, because we are calling this cost multiple times, but that's just a constant value. Okay, so that's the time is n log m, and space is going to be O of 1, because I don't think we're creating anything extra here. We're just using a left and a right pointer. But yeah, like I said, I think this solution is definitely not super intuitive. Let's see if they even give you these hints. Let's take a look. Change the elements into numbers already. Yeah, so they do give you, so I guess this gives you the hint that you can use the prefix sums. Like, I think knowing this, you can get a solution, but once again, it's not exactly easy to see. Like, you might definitely think that's not the case, and if you try every single number, like from the min to the, to the max, then that's going to be longer. Try finding the cost. Yeah, and so they are kind of giving you the hint of that, but yeah, like I said, I don't think it's super intuitive, and also this binary search is not super intuitive. You would need to know some math for this. But regardless, that's it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.